Hi guys, welcome back. Creating interactive AI avatars is a groundbreaking frontier in AI technology, which blends cutting-edge AI with immersive storytelling. And these dynamic, responsive avatars are among the most challenging innovation to build right now, and they require sophisticated integration of both real-time video generation and multimodal pipelines, text, video, audio, all the components, as well as adaptive behavior. So, and yet they are uh, one of the most desired creations. They can captivate audiences and they can disrupt many industries, including gaming, virtual reality, education, and entertainment. This video is first in the series of creating interactive virtual avatars from scratch. In this video, I'll talk about the first part of the puzzle, which is making the what I call voice to videos. Essentially, as the user speaks, the video switches based on what the user asks for. Okay, and I'll be using the Pipecat framework for this. I'll go into the architecture and the details and the code of that'll show how such an interactive framework is built. Okay, so now I'm going to play different videos based on voice instructions. So let me connect to the Pipecat backend. And on connecting, it says it has 3 videos to play. And which video would you like to play? So by voice instructions, I'm going to play one of these videos. Play Google video. Play Google video. Okay, so it started playing the Google video, Google I/O 25 video. There's a moment of delay between the instruction and the video. So let's try another one. Play Sam's video. Good. So that switches from Google to play Karpati video. Great. So switches to another video also quickly. What's happening behind the scenes is that when I give an instruction, it is the audio is converting to text, and that text is used to guide the LLM to generate video IDs, and the video IDs are then used to stream the corresponding videos. So this voice-driven demo, it might seem like a very simple one, but it's a crucial step in building conversational voice and video avatars where users can talk with video avatars dynamically and interactively. So with voice to playing a video pipeline, these are the essential steps that you're looking at. We start with a voice instruction, the audio packets, audio frames coming in. It goes through speech to text module, for example, Whisper or an online API like DeepGram, and that streams out tokens, transcript tokens, which go into a large language model. The LLM interprets the instruction and converts and figures out which video to play. So essentially, there is a tool call which parses the instruction and figures out the video ID that's supposed to be played. Okay, and this is the module that finally there is a module which takes the video ID and plays the video, um, for example, in the browser. Now this looks relatively straightforward, and the pipeline is implemented in Pipecat or LiveKit almost like this. The 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 catch is that all of this data is streamed. So for example, in the input LLM, LLM takes as input in a particular format, the chat template, where the user roles and the text and so on. So the streaming text has to be aggregated at this point. and convert in the format that LLM accepts. Similarly, LLM streams out its output, and um, the the full response needs to be aggregated. So you need modules for user aggregation and full response aggregation here. And once we have that, then we extract the video ID from it, and play the video. So there's this module essentially takes that full response and runs a video processor which reads the file and plays the video. That also reads the file um, and transmits, streams out the video frames one by one, which the video player is able to play. Cool. So this is the overall flow, and now we'll look at how exactly this is implemented in Pipecat. Great. So now let's look at how this pipeline is implemented in Pipecat. So we jump right into the middle of the pipeline. This is the how most of the pipelines look like. Transport input. This is using small WebRTC transport. Connects to STT, which is a Whisper module. Aggregates stuff for the LLM. This is this RTVI module, which is also a frame transformer, which handles the protocol between the client and the server. So client can ask the server to run some tool call, and server can send back error message. That's just for client server interaction. So we can basically ignore it to understand the pipeline. So as the user says, audio comes in, STT turns into text. That goes to the LLM. LLM gets an instruction. So for example, I'll ask the LLM to run a particular video, and LLM has to interpret that instruction and convert it into a video ID that is handled by the video processor, which reads the video and turns it into a stream of video frames, which finally goes to the transport output and is shown on the UI as in the demo that you saw. So yeah, one more detail here is that everything streams here. So like I said, there is a aggregator which aggregates the output from the streaming output from STT Whisper, and then there is a response aggregator from LLM. LLM streams out tokens, so it just collects all the response into a single text value. Usually we have the output of the LLM connects to a TTS, so that I usually have a sentence aggregator which feeds into the TTS. Okay, so I have separate videos on how frame transformers work and core principles of Pipecat design. Now, how every frame processor takes in a particular data type of frames, stream of frames as input, and outputs another data type of that. So you can look at it to understand that better. This is just an application of that. Okay, so this is the pipeline, and the real work happens in this video processor, which takes in a video ID and generates the frames from that video. Okay, so before we look at that, let's just look at the LLM, which is I'm using Grok, and the context for the LLM is specified through this context, which is standard OpenAI format. I have the system instructions that start by greeting the user warmly. You are a helpful robot who can play videos for the user. You have access to the following videos, and there are a bunch of video names that I've specified here. And the files for each of the files is stored locally on the disk. Ask which video to play depending on the user's choice. Output only the video ID in JSON format without those tags. Okay. So what LLM does is when I say play Sam video, that it looks up this array and outputs video ID 2, which is then taken over by the video processor. Okay, so that's how that's how the LLM is implemented. The STT is pretty standard. I'll just, this is the STT, Whisper STT service module in Pipecat. Okay, that streams out text. Okay, so now let's look at just the core part of the of this pipeline. This is the video processor class, and we initialize the current video ID to 0, and it's playing by default. It's playing the current video ID. Okay, and it has the list of file names for each of the video IDs. And the core function, this is a frame processor, the core processor. So this is the core function is process frame, which takes as frame as input of different data types, and with the direction, which direction it goes in. So like the standard process frame, if this module doesn't care about that frame type, then it just keeps pushing the frame without disturbing, so that the other processors that depend on that frame pass through. What it cares about is this LLM full response frame. Okay, and so when it gets this LLM, this is the frame with video ID from the LLM. It reads the text, loads the JSON, and picks the video ID field. It sets the current video ID to video ID -1 and updates video to that. So this update video sets it to the stream the desired video. Okay, so let's see what update video does. Update video picks the file name corresponding to video ID and uses OpenCV to open the video, and the get is set, the cap variable is set. The get frame function is called when, okay, so it is called here when the input, so anytime it receives an input image that so I've synchronized it with the input image frames. Anytime as long as the input video keeps flowing in, it outputs the next frame of the current video. This is a hack to make minimal changes from the standard example. Otherwise, we'll have to configure some of the when the video is played. Okay, so get frame. If it gets a new video ID, update the video, and then read the handle for the video, OpenCV handle, set loop back to the start and start playing. There's a bunch of resize, and this is the output image raw frames that's created based on the current frame read and the width height dimension, the format. There's a bunch of format issues here, so you'll have to play around to figure out the right way to pass in the format. Okay, so, but essentially it reads the current frame, one frame, and returns back to the process frame. Process frame just returns it back. Okay, so yeah, sorry. So process frame gets the frame and pushes it onto the channel, onto the queue of the next frame process. Okay, so that's the quick overview of how the video processor works. Okay, so this voice to video, again, you start from the voice, STT, goes to LLM, instructions, figures out the video ID, gets aggregated here, sent to video processor picks the correct video to play and iteratively outputs the frame to the output which is in the UI. It's a standard pipeline task, which is Other parts of the code are pretty similar to any standard Pipecat pipeline. Okay, so that's how the basic voice to video pipeline is interactive application is designed. And this is still far from you talking to avatar guided by your voice and video. Okay, so this is the first part of the puzzle. There are a bunch of other pieces of the puzzle. I'll quickly talk through that. One thing that you might have noticed right here is the interruption. Okay, so if the video is playing and we want to interrupt it, uh, and the user asks for another video, you want to switch quickly, and you want to avoid uh, playing the current video um, until the new video handle is set. Okay, so you use the start interruption frame to set the self interruption to true, and then if the interruption if not being interrupted, then you push the frames. Otherwise, you just stop. There's no video being transmitted from this. So that's a quick that's a small part of the pipeline that makes the UX better. Okay. You might have noticed that the video was playing in the demo, but there wasn't any audio. You couldn't hear the audio from the demo. You can check back. So that needs some more work. You need to play also the audio stream from the file. Okay, so that'll make a complete experience. The full video is talking back to you. Okay, and final part of puzzle is that this video is generated offline. That's not how a real time or interactive avatar works. The video has to be generated on the fly based on what the user said. Okay, so how do you generate such a video in real time on the which is also based on what the user said? So part of the puzzle is already there. The LLM can determine um, what the response should be. It's probably going to use some RAG if the response is based on some set of documents, some information stored in the background. And then once you have the text of output, how do you generate a video in real time? And that I'll cover in another video probably. Uh, how do you generate such a video in real time and play it back? So there are a bunch of system related issues there to make the full end-to-end avatar work. So I hope this was useful. Yeah, we went through how to build a basic voice to video application, starting from the high level architecture all the way down to the Pipecat code. If you have any questions, feel free to comment, and and do watch the other videos for understanding more details of the pipeline.